Hi, I'm Carl Loveridge from Extra Cheesy Games, and today I'm going to present a tutorial on how I colorize my characters in my game Humans Must Eat. Now, the technique I'm going to show you is about as simple version as I could think of to explain this technique, and there's lots of ways you can do colorization, but I feel like let's start at the very basic version of it, and eventually I'll do some other lessons to do more complicated versions. So let me show you what I'm doing here. This is one of the customers, and you know what? I don't know if I'm completely happy with him, but at least you'll get the idea of what I present here. So the character is actually made of two separate parts. The head and the body would be interchanged, and I've designed these so that the pieces can be placed with each other so that I could have a different head, a different body, different colors. And so what I've done is I've written a shader here that I can colorize the hair and the body. Now, right now what you're seeing is they're both being colorized at the same time, and that's because I'm in Unity's editor. What will happen is in game at runtime, I actually do have independent control where I can tell the shaders to be a specific color. But for the editor, this is the way this wires up. And both the head and the body share the same material. Okay, so let's look at some basic math of what's going on here, and then let's look at the shader. All right, so to do this colorization, there's basically three things you need to understand. If you take the color red and multiply it against black, you'll get the color black. If you take the color red and multiply it against white, you'll get red. And if you take the color red and multiply it against a tonal map or a grayscale map, you will get shades of that red, okay? And that's a very basic breakdown. Now, you know from a previous lesson that in reality, these values here are not the 0 to 255 range, but they're actually 1, 0, 0, and then the rest of these would be, that's the different number space that is between what we might see in Photoshop and what is in a shader. So just be aware of that. I don't even care about this, so let's not save this. All right, so let's look at the map here, because this is where the fun stuff begins. So this is the map of the body, and you'll notice that the shirt is white, or in this case, it's kind of a grayscale. And this map, in case you're wondering, I believe is a 1024. And one thing you have to do is 1024. When you make your textures for your characters or whatever, you kind of have to think about how much screen space they're going to have. I'm kind of going off on a small tangent here, but when you see a character up this close and personal, you might think, oh, that's kind of mushy, but in reality, the game plays way back here, right? So I don't really get that much detail, and so if it's slightly mushy, it actually reads better from a distance. So just know that even though I believe this little piece of this is actually a 256, it's sufficient for what I'm doing with this guy. Shirt is gray, and the magic of how this gets colorized is down here in the alpha, because it's the alpha where I identify what is going to be colorized. So let's say, for example, let's just show you how this works. If I was to go in here and I know roughly where the hands are. Now, normally you'd paint this in a program like Substance Painter, or if you do it in Photoshop, you can do it in Photoshop. This would be a similar thing. Nice thing is Substance Painter does that tonal mapping for me by baking the lighting. Let's just show you what happens here if I modify the alpha. Okay. If I come down close, now you'll notice the hands are yellow, and that's because I just identified in the map where that is. So if I put it back, now they're back to white. Okay. All right. So let's look at the shader. Now, one thing you might be asking, well, why does the face get colorized? Well, the face, in my case here, is actually a separate mesh that gets in here. And I'll do another tutorial another day about how I'm masking these eyes inside of here, because this is using a more advanced technique using stencils. Not going to talk about that today, but just kind of so you, in case you were wondering. Let's go look at the shader. All right, so I'm using this as a surface shader. Now, most of the shaders I'm using in my game are a surface shader, and instead of a Vertex Fragment program, simply because my game isn't run, I don't put so much content in there that I have to be extremely careful with my shaders. Again, my game is a mobile game, and you know, you can get away with something expensive if the whole thing is running fine, right? So it's all about budgets and so forth. Let's just walk through this though. All right, so at the top here, I have the color I want to use as the colorization, and then the texture, excuse me, that I'm going to read. And then below, this is just going to be a standard Lambert shader. It's not a standard shader, it's a Lambert shader, which means I don't get any reflectivity, any specularity, or anything in there. Down here is where the code actually runs inside of this function called surf. And right here, I'm reading the texture. Okay. Now, to make this a little more clear, I identify what parts of the map do what. So, in other words, the diffuse reads in a fixed 4, so I'm getting RGB and then A, but rather than using the name diffuse.A to get it, I rename it, I give myself a much clearer name, I call this my mask. And I would get in the habit of doing that with shaders, because this may look more expensive. Anybody that's coded, this would probably be more expensive in a programming language like C# or C++. But shaders, even though they are a version of C, they're extremely efficient, and they encourage this kind of documenting your stuff and making it clear, because it'll compile out, and there will be absolutely no time difference in this. The thing you're doing for yourself here is you're just making this clearer for you to understand what you're doing. Now, I'm going to actually comment this code out and explain this in a minute. There's two ways you could do this colorization. I'm going to show you what you just saw was, well, I'm not going to explain. This is the colorizing with a lerp. And if you look back at here in Unity, it looks identical. And the way a lerp works, a lerp is one of those things you use a lot inside of shaders. Lerp stands for linear interpolation. And this is basically what a lerp does. You take a color A and you take a color B, and then you take some percentage equals your result. All right. So in this case, my diffuse is the raw color that came from the map. The colorized version, if you notice here, I took the color of the map and times it by the color, and I did the full colorized without any masking, and then I multiplied against the mask. But let's watch what happens if I take out that word mask and just type in the numbers in directly. Let's go back in here. Now, let's see, I did an error here. Let's see, color, lerpolate, diffuse, colorize, 0. Why am I getting an error on that? Oh, take your comments out, Carl. Go back out there. Okay, and if you pay attention to your errors that would have come out of the console, you'd get that. Sorry about that. Okay, so there he is at 0%, and if I send this up to 100%, now he's all colorized, right? Now he's got jaundice, all right? But because we're passing in this mask, now we're getting it to isolate regions of the map. So back to Photoshop, our mask looks like this. So black is where I want one extreme and white is the other, and you actually can do shades of gray. So I'm not talking about some weird porno that's out there on the movie scene. Let's say this is 0.5. Now you'll get a blade of the color. Now it may not be as clear with yellow, but if you go to something more extreme, like red, you kind of can see more what's going on there. So you get all the colors in between there. So that's using the lerping method, and let's put this back to a mask. Now another method I use, and I wish there was a more clear way to know how shaders performance works, and so the other technique I'm going to show you, I've heard that lerps are a little bit expensive. I could be completely wrong about that. I have no proof. It's hard to prove this, but I'm going to say, let's pretend it is, but let me show you a second way of doing this colorization. And this is by using what I call a knockout mask. And you'll look, it's exactly the same result. But let's kind of break this down into pieces, what's happening in here. So this is a very common way I deal with isolating stuff inside of shader. If I want to see just a particular component, I will go to the very end of where my code's going, and instead of letting it pipe through the result that should be there, I just bypass it and put in what I want to see. So I'm going to put in, what does the mask look like when it's colorized? And see, this is black, right? So, and what is colorized is red. And if I do the opposite and I look at the color, I get the opposite. So at the end, if I just add those two together, I get the final result. This is another common way you can do this. Is it faster? Is it slower? You know what? I don't know. I do know that, and you know, people may argue with this. I don't have a very good example of this. I swear that with lerping, I get halos around this content. Like, let's say at the edge of your texture you had red and you had a print and it was backed against white. What'll happen, you'll see, is that sometimes you'll get the color doesn't quite transition properly, and you'll get a halo. And I'll have to see if I can find an example to prove whether this works or not. I just know this is sometimes a little clearer. Well, sorry, this one might not be as clear when you look at it on the surface, but when you kind of break it down, you know exactly what you're getting with this add and subtracting, versus the lerping is basically saying, I'm going to put X percentage of this and X percentage of that, Y percentage of that, put them together, and then that's the result. So that is the final part of this tutorial. The Vertex Fragment version is very similar. All I do, actually, is this the one? Vertex Fragment. No, this was a test case, so just ignore that. That was a different one. Actually, I thought I did write one. Yeah, I did right here. So if you want to look at a Vertex Fragment version of that same basic shader, you can look at it here. The other thing I would point out with this, this is maybe just a small little tidbit of information. In the Vertex program, I'm doing the same stuff where I'm doing a step that you don't see in a Surface program. I'm actually multiplying the vertex by a matrix here, and I'm going to explain this statement here in just a second. And then over here, I'm doing what's called where it transforms the material to the texture. So let me just change this so you can see what's going on here, just to further your education on shaders. Okay, so I'm going to change this from this character colorization to character colorize FV, which is a surface fragment. You'll notice first thing that happened when that ran is my lighting went away. But there's still some lighting. Where's that lighting come from? Well, it's the way this thing was textured was to work in a lit environment, and that's my fallback if I start running into performance issues, is I would go back into this way, where the lighting would be done and baked into the texture. Let me show you. Oh, you're all familiar with this. This is what I was leading to. If you've seen this, where you can scroll your material or repeat it, that is actually occurring down in here by this statement here. I'm going to show you where you can find that, but I'm going to turn it off, and if you comment this out, now this becomes dead. You don't get any of this. So, where does these little macro functions come from? And I'll give you the hint. What you're looking at is this statement right up here, this include. This is a bunch of functions that are included within Unity that has functions to do things like this. You could do that yourself. You could code that yourself, but why do it if they've done it? And you're going to assume if they did it, they probably found the most efficient way of doing it. And in fact, this statement right here, this is different than it was prior to, I don't know if it was version 5.5 of Unity. They actually switched this to, used to be a multiply matrix function, and they changed this Unity object to clip position. Let's go look at the code briefly, just so you know where this is located. Now, I'm going to do this on a Mac, but PC, it's got to be somewhere similar. So if you go into your applications and you go hunt down Unity, if you right-click in Unity, you can show this package. And you know what? I'm showing you the back door to this. You actually can go up and download this stuff from Unity's site. I'll have to take a moment and see if I can find that for you here. CG. So if I follow this down into their contents, CG includes. There is the CG Unity CG.cginc file. So if I open this with, let's say, Text Wrangler, now you can see where these functions are. So there is that transform text is right there, and you can see the math that they're doing here to do this. The same goes for this Unity object clip to clip position. Let me go find that. Now there's more files than just this guy. Now see, there's some things actually in here using this. Let's see, you just got to hunt it down till you find the actual function. That is still not it. Several things use that. There he is. Okay, so basically this is the function, and these things are really cryptic. You know, I know guys that program that are hardcore programmers. They go, "Oh, that is so easy." For an artist programmer like I am, which I am, I look at this and I go, "Could you guys possibly make this feel more difficult to read?" Anyway, so I'm doing an inline piece of code here, and it's doing an if test. And if Unity is using pre-multiplied matrix, it does this. If it's not, it does it this version. I don't know, if I had to sit there and do a lecture on the math, I would say I would fail. But I do know that basically they're taking the matrix and multiplying against the position. That takes it from object space out into world space, and then, actually, is that right? Model view projection. So it's taking it from the model position, putting it where it belongs in space, figures out the where the camera is, and then how the projection goes. Frankly, it's been a while since I reviewed my matrix math. That's a terrible explanation, but in essence, you don't really. It's like the way I look at doing shaders is frankly like you could be a mechanic or you could be the driver of the car. Frankly, once you understand a few basic rules, I forget this stuff down to the nuts and bolts how it works. Someday I will probably do a review of this and get my mind fresh on it again. And maybe I'll do a video where I'll show you how matrices are used to compute vertex positions. But as an artist goes, I don't think most of us care, so I'm not even going to bother right here. Anyway, that's where that belongs. That is my tutorial on how to colorize. Now, this tutorial was very simple. You can do multiple toning. You can repurpose things. The thing you run into with shaders is you only have so much to work with. For example, in this texture, I only had an RGB channel, which was dedicated to my color, and then the alpha channel, which was dedicated to the mask. If you want to do two-toning, where you wanted to identify more stuff, you're going to have to start burning a few more maps to start to do that. And I'll do that in another tutorial. But I wanted to whet your appetite with how I do colorization. There's a lot of ways to skin this cat. And so if you have any questions, if I haven't made something clear, please post a comment. I'd be happy to explain it. One thing I know about my brain is as I'm talking, I don't oftentimes clarify things. I'm always amazed by people that can talk and be so clear, and that's a gift. If you can do that, you've got a gift. And for me, I'll tend to kind of, my mind's focused on something and my mouth's going off in some weird direction. So if I do that, just know that's just my way. But appreciate you watching. Give it a thumbs up if you liked it, and if you have questions, post it. Thank you. Thanks for watching.